Okay, let's have a look at the second question here, which is 3x1 plus 2x2 equals 6 and 9x1 plus 4x2 equals 36. We're going to now proceed directly to the matrix formulation and the matrix solution of this system of linear equations. So the augmented matrix is there's 3, 2, 9, 4, a line to separate the left-hand side of the equation from the right-hand side of the equation, and 6, 36 on the right-hand side. And now we're going to row reduce. Okay. And the idea is that we're going to use this entry here. We're going to use this entry here to get rid of the entry below it. Okay, how are we going to do that? Well, we're going to take the second row and we're going to subtract a multiple of the first row. In fact, we're going to do exactly the same thing that we did in the previous question. So we're going to set row 2 equal to row 2 minus 3 times row 1. It's telling us that we're going to replace row 2. So the new row 2 is the old row 2 minus 3 times the old row 1. And the row 1 doesn't change. 3, 2, 6 is still there. And now this row minus 3 times the first row. 9 minus 3 times 3 is 0. 4 minus 3 times 2 is minus 2. And 36 minus 3 times 6 is 18. So what can we deduce now that we've row reduced the matrix into this form? This is already an agreeable form. We can see that the initial entries in each of the rows, right here, are non-zero. Those are non-zero entries in the initial entries of each row. And there's such a pivot entry on the left-hand side of each row. And from that, we can conclude that there is a solution. In fact, there's a unique solution. And the way I'm going to say that is there's a unique solution since each column, each left-hand column, is a pivot column. So a pivot column is a column that contains a pivot entry, which is a non-zero entry, which is the first one in this row. So this is a pivot entry, this is a pivot entry, and these columns are both pivot columns. All right, so let's graph these lines and see that there really is a unique solution. All right, so we have two axes. X1 and X2 are their labels. And the first line we've already graphed. So something like this. 1, 2, 3, 4, 5, 6, etc. Okay, what did the first line look like? Well, it had, let me remind myself, to find the x-intercept, we set x2 equal to 0. So if we set x2 equal to 0, we get x1 equals 2. And to find the y-intercept, which is actually the x2 intercept because the coordinate is x2, we set x1 equal to 0 and solve for x2 to get 3. All right. So we had those two as the intercepts, and there was the line there. All right, what about the second equation? To find its x1 intercept, we should set x2 equal to 0, in which case x1 is 36 over 9, which is 4. To find the x2 intercept, we should set x1 equal to 0. So if we set x1 equal to 0, then x2 is equal to 9. Where is 9 on our picture? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up here probably somewhere. All right. Okay, so then the line will be like this. It's no longer parallel, and there will be a point of intersection, but it will be down here somewhere. And so if we actually solved this system, carried out the row reduction to get a solution, we would expect to get a point which is somewhere down here from the diagram. So we have a situation where we have lines which are not parallel, and so they're meeting at a unique point. That's the geometrical content of the algebraic system.